All right, so this is the last rock family that we're going to cover because this is the last rock family. So this is metamorphic rocks, and right. So metamorphic rocks. This will run a little animation. It kind of shows a change. This will make more sense in a little bit. But the main thing with metamorphic rocks is change. They change form. So you start with one kind of rock, something happens to it, and then you end up with a different type of rock. So like you start with igneous rock, some things happen to it, and then you end up with a metamorphic rock. So there are three causes for the change in rocks to make a metamorphic rock. First was pressure. So if it's underground and there's the weight of all of this rock pushing down on it, all that pressure. Heat. So heat from underground magma, and then chemicals, which these are natural chemicals. They're not. It's not like an accident or a chemical spill or something like that. But pressure and heat, those are the two main ones. Those are the main ones. Pressure and heat. Chemicals, not so much. All right, a couple different types of formation, or the way that these metamorphic rocks are formed. So the first one is regional. So this covers a large area. And the big thing of that is it's caused by pressure. So this happens a lot where plates are moving towards each other. So you have the pressure of these plates moving towards each other, or where they collide. Where they collide, it can also make mountains. So on the surface, you'll see mountains. And then underground, deep underground, there's pressure that's causing regional metamorphism. So it's causing rocks to change. Like I said, this is a big area. If there's a region, that's a large area. It's not a small area. The other type is contact metamorphism. So contact, like if I'm making contact with the board, I'm touching it. So contact, it's much smaller, it's caused by heat. So if there's an underground magma chamber, the rock that's around that magma chamber will be changed because of the heat. So that's where the metamorphism takes place. Some of these rocks that are on the edges of the magma chamber, they'll be heated up, they get hot. They don't melt, but they are changed from the heat. So that's contact metamorphism. That's caused by heat. So regional is pressure, contact is heat. Guys. All right, so here's the term foliated. So this is an important term that describes some metamorphic rocks. It's also a good way to start to identify an unknown metamorphic rock. And foliated just means layers. So if there's a metamorphic rock and it looks like it has layers or stripes, that's foliated. The way this happens, or what causes this, is when igneous rocks form, these crystals are growing in all different directions. They're growing, just all over the place. But when that rock is compressed and put under pressure, all those crystals that are all over the place, they're kind of pushed together so they're all in line. So it's the same crystals and the same minerals, but now they're all running in the same direction. So it looks like there are stripes, or it looks like there are bands or layers. So over here, like I said, they're all over the place, but here they're all in line. So you end up with something that's foliated. It looks like a foliated rock. So with metamorphic rocks, you have to have a rock to start with. You start with a rock, and something happens, then you end up with a new rock. So the rock you start with is called the protolith, which means first rock. Proto means first. Lith, we already saw, means rock. Proto is the same root, like prototype. Like if a car company is, going to build a new car, they're going to build a prototype and they're going to test it, and they're going to see, what's wrong with it. They're going to see what works. They don't just start producing it and start selling it immediately. They have to test it. So that's the first one. So this first rock, it's also called the parent rock. So the parent rock is the rock that you start with, then something happens, then you get something different. So with this example, the parent rock is granite, and then that gives rise to this foliated metamorphic rock called gneiss. So even though there's a G, it's a silent G, so it's pronounced gneiss. So granite's the parent rock. Expose that to a lot of pressure and some heat, and then that will form gneiss. A couple of examples of that. Shale is a sedimentary rock. That's the parent rock. Slate. So that's the parent rock to slate. So we just said that foliated rocks have layers, but if a metamorphic rock does not have layers, then it can be described as non-foliated. So not a very exciting name, but it's descriptive. So foliated means layers. Non, that prefix just means none or none, so no layers. So these are caused by heat. So foliated rocks are created by pressure. Non-foliated are created by heat. So these are the rocks that are going to be around these magma chambers that are changed. And they're changed because of the heat of that magma. A few examples. Limestone, that's the parent rock to marble. And I put acid down here because limestone is cemented together with calcite. Calcite is a carbonate. And if you put hydrochloric acid on this, it will bubble and fizz and all kinds of stuff. Same thing with marble. Because that calcite's still there, it's kind of in a little bit different arrangement than it was in a limestone. Here in Indiana, and especially in southern Indiana, we have a lot of limestone, but we don't have marble. So we have a lot of this, but we don't have this. The reason we don't have this is because we don't have volcanoes. We don't have underground magma chambers. We don't have the heat that's necessary to change limestone into marble. We don't have that heat here. So we just have the limestone. Another example of a non-foliated rock that's created by heat. You have the parent rock sandstone, and that gives rise to quartzite. So when sandstone is exposed to heat, the grains of sand will actually kind of melt and fuse to form larger crystals in the quartzite. And since most sand is quartz, it's fitting that the name of this rock is quartzite, because now that's what it's made of pretty much, is quartz. But quartzite is much, much harder than sandstone. Much harder than sandstone, much more durable. And then the last one, these are two different types of coal. So coal, we use that to burn, to generate heat, to generate electricity. This first one, the parent rock, the sedimentary rock, it's called bituminous coal. It's the most common type of coal. It's soft. It's readily available. Expose that to heat, and it changes that into a type of coal called anthracite. It looks different. It's much more glossy. It almost looks metallic. It's much more brittle, but it also burns hotter. So it's more desirable than bituminous, but there's also not as much of it, so it's more expensive. So bituminous is the parent rock, and that gives rise to anthracite.